So the name of our subject is soft computing, and let's see what is meant by soft computing. So we all know what is meant by hard computing first of all. So hard computing means it's the actual programming that you have been learning so far. You will give an exact input to the system and you will get an exact output. So based on some program, okay, if you're going to feed some input to your program, if this is your program, then you will get an exact output for that program. Whereas soft computing actually relies upon some ambiguous and noisy type of data, whereas hard computing works on exact type of data, and also it can perform parallel computation. Here it is only sequential. It means one by one the lines are executed for the normal programming or hard computing. Then this will only generate an approximate result, whereas this is going to give you a correct result. For example, if you have to say add two numbers, that will add 2 plus 3 and you will get an exact answer as 5. Whereas soft computing means it is actually used for predicting some kind of output where you don't know what is the result. Maybe if COVID will come in 2030. So based on the previous data that is being fed onto it, it will generate some kind of result and it will say no, there is so much amount of likely chance that there is going to be COVID in this year. So such type of results can be generated, like prediction, all those kind of can be done using soft computing. So these are some of the differences between soft computing and hard computing. This is only for your introduction. So in our syllabus, in every module we have got one method of soft computing. So the first module is based on artificial neural network or ANN. So in this module we're going to learn about what is meant by artificial neural network and how it can be able to solve problems, etc. So basically it's a theoretical module, and here regarding the artificial neural network, it is actually an algorithm or actual hardware whose design is inspired by our actual brain. That is why it is called as artificial neural network. So neural network is what we have in our body. So it is being inspired by that and it has been made. It's actually an algorithm. So it has to ability to learn by examples. So based upon examples or the inputs it has been fed into it, it will be trained and then it can learn. Just like a brain can learn, similarly artificial neural network also has the ability to learn. So it is also called as artificial neural net. Instead of network, the short form is also called as net. Then it tries to mimic the human brain and the human neurons. So let's see how this is being implemented in the next slide. So next, before we understand what is meant by an artificial neural network, we have to understand the structure of a biological neuron. So biological neuron, this is the structure. So in this there are about 4 main parts for it. Okay, so the first part is called as the soma or the cell body. So cell body is where the nucleus is present. So this is the nucleus, and the processing takes place inside this cell body. So this is the cell body. Okay, then we have got the dendrites. Dendrites means this is going to provide connection to other neurons. So these nerve endings, or this is called as the dendrites. Then we have got axon. So axon causes impulse of neuron. So axon is this. So once the processing takes place inside the cell body, then it will travel all the way. The impulse, the electrical impulse will travel all the way through the axon, and then it goes over to the other neurons. Then synapse. Synapse is a bulb-like organ, and it is through which that it connects to other neurons. So you can see over here a bulb-like structure which is going to be connected to other neurons. This is called as synapse. You can see it over here. Okay, so the connection, the end of the connections of the dendrites, that is called as synapse. So this is the four main parts of a biological neuron, and based on this an artificial neuron has been created. Next we will study the working of an artificial neural network. So we saw that there are four parts and how it is going to work. That is what we are going to study. So working of an artificial neural network or an artificial neuron. So this is actually the biological part of it. So electrical signals from other neurons are transmitted to the cell body through dendrites. So this is where electrical signals from other neurons are going to come to this cell body. So the cell body will process the incoming activity signals and it will convert into an output activation signal. So it is going to process all the electrical signals which are going to come from other neurons, and the processing will take place here in the nucleus, and it is going to convert it into an activation signal. Again, an electrical signal output will be generated, and that is going to pass through the axon, and then it will be passed on to the neurons of or the dendrites of other neurons, and then again processing will take place there, and then the connection is just going on like that. So this is how an artificial neuron is going to work. So it is using the synapse and the dendrites. The signals are transmitted from one neuron to the next neuron. So next is we are going to study the structure of an artificial neuron or the mathematical model of an artificial neuron, which is inspired by the biological neuron. So we saw that inside a biological neuron, various inputs are going to come from other neurons. It will be processed inside the cell body, and then an output is generated, and this output will be given to various other neurons. This is what we saw. So here let us assume that the inputs are x1 up till xn. So these are the inputs. Now we have something called as weights over here. So weights means weights will have the value between 0 and 1. All the weights will have values between 0 and 1. And what weights does is it is going to be multiplied with the input, so that the input will have certain effect on the cell body. That is, if the weight is 0 means it will not have any effect inside the processing. If it is having a weight 0.5 means only so much importance will be given to that particular value. So weights actually mean the amount of priority or the importance that can be given to the input. So if you don't want any input, it can be nullified by giving a 0 weight, or if you want a particular input, full effect of it, you can give the value 1. Then these weights are multiplied by the input, and then that is going to be summed inside the cell body. Then you are going to apply a function. Some particular activation function is going to be applied onto that sum, and then the output is going to be generated. So inside the cell body, two functions are taking place. One is the weighted sum, that is sigma xi wi. That is the first output or the first process that is taking place inside the cell body. And the second one is, on to this you are going to apply an activation function. So this will give your output y. So this is what I explained. The processing element. The processing element means the cell body. The cell body will calculate the net input, and the net input is calculated as the weighted sum of all the inputs, and that will give you y in. So it can be also written like this: sigma I equal to 1 to n x of I into w of I. This is also called as weighted input. Then after that, inside the cell body, we saw that it is going to pass through a function f called as activation function, and that will give the final output y. So final output y is generated by f of y in. So this activation function, what it is going to do is it is going to squash the input between 0 and 1. So when you take the weighted sum, xi wi, it can finally become a very large value. So you are going to squash that value so that it becomes a value between 0 and 1. So that is the function activation function is doing. So after squashing that input, we will get the output to be between the range of 0 to 1. Okay, so let us imagine that we got the output as a value like 0.6. So we would have set a particular threshold value, say 0.5. That is a preset value. We're going to set the threshold to be some value between 0 and 1, which is, let us say it is going to be 0.5. So the output that we got is 0.6. So if the output that we got, if that output is greater than the threshold, then the output y of the neuron will be equal to 1, and we will say that the neuron has been fired. The neuron is going to generate an output. If the output is less than the threshold, then the output y generated will be equal to 0, and we will say that the neuron is not going to fire, or the neuron is off. So here our output is 0.6 and the threshold is only 0.5. So the output value is generated, which is going to be y equal to 1. So initially you're going to take all the inputs, you're going to take the weighted sum, then you're going to apply an activation function, squash the value to between 0 and 1. We're going to check that value with the threshold, and if it is greater than the threshold, the output is generated, else the output will be 0 for that neuron. So this is the basic working of an artificial neuron. Next, let us see what are the basic types of classification of the models of artificial neural network. So you can divide it based on 3 types or 3 methods. So one is based on the synaptic connection, next is based on the training or the learning rule, and then next is based on the activation function. So we'll see each one of them. So first, based on the synaptic connection, or how one neuron is connected to the next neuron. So again, that is divided into 2 types. So that is single layer feed forward network and multi-layer feed forward network. In single layer feed forward network, we know that this is the input layer. So you have neurons starting from x1 up till xn. You can have n number of neurons, and also the output will have y1 to ym. You can have different number for both input and output. So here we have taken input is having n and output is having m number of neurons, and each of the input neuron will be connected to the output layer through weights, and that is called as feed forward network. So all the arrows have to go in the forward direction. So first you draw like this, and then for example I'm just showing 3 neurons over here. So I'll connect the first input x1 to the output y1, then next one is also connected, and likewise. So how will you write the weights? First input to first output w11, second first output to second input w12, and first output to the third output, that will be w13. Similarly you can do for the other neurons also. So first you will write the subscript of the input, and second you will write the subscript of the output. So based upon the sum that is coming to this particular neuron, it will be either fired or it will not be fired. So maybe y1 will be fired, y2 will not be fired, again y3 may be fired, and so on. So it will go like that. So one output is generated for per node. So there will be m number of output for this neural network. Next is multi-layer feed forward network. In multi-layer feed forward network, we have one input layer, one output layer, and more than one or one hidden layer. So at least there will be one hidden layer in this. So here the figure is having two sets of hidden layer, and every one of them is connected to the next layer. So that is why it is called as a feed forward network. So you can see that all the arrows are going in the forward direction. Then x1 is connected to z1, x1 is also connected to z2, and x1 is connected to zk. So how will you write the weights? So here it will be w11, here it will be w12, here it will be w13, and so on, like that. Here it will be w2, 3, and so on. So it means that the second layer to the third layer, and so on. So that is how we will write the weight for each one of them. And these weights represent whether it will have an effect on, whether that particular input will have an effect on the next layer. So finally you're going to get an output for each of these nodes. So sometimes it may fire, sometimes it may not give you an output. Next is based on the training rules. That is how you are going to train a network so that it can do its application, or how it is going to learn something so that it can learn its application. Based on that we can do another type of classification. So this learning method can be divided into three, that is supervised learning, unsupervised learning, and the last one is called as reinforcement learning. So we'll see them one by one. In supervised learning, the learning is going to be done with the help of a teacher. So teacher means either a human will interfere and it is going to correct that network so that it is going to generate the required type of output. For example, imagine that I have got an image recognition system. So in that I am going to feed with several images of cat and dog and other animals to it. So it will take the first image. Let us imagine that it is the image of a cat. So I should get the output as 1. So if I get the output as 1, then it is correct, then I don't have to do any other job based on it. So next I am giving the image of another cat. So this image recognition software has to identify it, but unfortunately it is going to give me the output as 0, which means I am not getting the required output. So there is an error. So this system has an error, and we know that the desired output is 1, but I got the actual output as 0. So I have an error, and this error fed back into the network, and I will correct the weight. All I can adjust is the weight. I cannot adjust the input, but I can adjust the weight of the network. There are many weights available, so I can adjust any one of these weights, and I can adjust these weights so that the output will change to 1. So once the output changes to 1, my system has actually understood that it is a cat image and it is generating the correct output. So this 0 I am going to change to 1 by changing the weight. So that is called as supervised learning. So next, if I am feeding the image of a dog, that should actually give me the output 0. If it is not giving me 0, I'll again feed back, and I'll take the error, I'll feed back, I'll change the weight, and then I will generate the required output. So by doing with so many set of input or so many set of input images, I'm going to train this network so that any image of cat that you give it, it is going to recognize that it is a cat itself. So that is how supervised learning will take place. So this is also called as an actual output vector. What is the value that is generated by showing some figure or whatever input that you are feeding to the network. And this desired output is also called as the target output vector. That is what is actually required by us. That is the target what we are supposed to get. Okay. So based on the error between the actual and the target, you are going to feed back to the network, change the weight, and you will get some required output. Based on the learning method, the second one is called as unsupervised learning. In unsupervised learning, we do not have a supervisor, or we do not have a teacher. So without the help of a teacher, it is going to learn by itself. That is, the network is going to learn what type of output that it must generate. For example, we know that a tadpole learns to swim by itself. So without teaching, the time it is born itself, it is going to start swimming. So there is no teacher for it. So here also we do not have a target output, and there is also no feedback to inform whether the output is correct or wrong. It will learn by itself automatically. So this type of learning is used in applications where you have to discover the pattern, or it will form various clusters. So this is also called as a self-organizing network. So here in the previous case we knew what is the desired output, so that is called as supervised learning. Whereas in unsupervised learning, what is happening is that the network, it's going to generate a set of outputs which are together, so that it will understand that okay, these set of outputs are together, so that is going to form one cluster. So for classification problems, we can use this kind of method or unsupervised method. The third type of learning is called as reinforcement learning, and it is a method which is very similar to supervised learning. So here only the terms are different, where everything is same. So instead of feedback signal, here it is also called as reinforcement signal, and new two terms are actually reward, that is if it shows the desired behavior or the desired output is given, then some reward points are given, and if it is showing some undesired behavior, then some punishment is given. So that is the basic idea of reinforcement learning.